now I help manage this area of the center, which is our prototyping area.
Awesome.
And then we also run a lot of medical labs and corporate labs, and I project lead on our ophthalmology lab, and then I do prototyping lead on our medical device lab.
Cool.
So
okay.
I do a lot. I do
Yeah.
research, design, prototyping, and then a handful of administrative stuff.
Nice.
Here, the models we make are really concepts or rough prototypes of new ideas.
Right.
It never
okay.
gets to that really finished stage.
Right, trying to
Yeah.
figure out how it works or whether like the idea is feasible. It's not necessarily about trying to sell it to a client, would you say?
Right.
It's more about like, does this concept work?
Right.
Okay.
Does the concept work? Does the engineering work? Is it
Yeah.
something that's the right size and easy to hold?
Cool.
Unlike some professional model shops where they're really gonna try and make a model that impresses based on its paint and
Sure.
finish
Yeah.
and how well the parts were cut.
Right.
Here we're printing things quickly because we want to get the idea out
Got
and
it.
just test out theories.
Right. Test different ideas,
yeah.
cut them,
Right.
use them, right.
So,
improve.
And that's how the space is, we have the sort of messy, dirty, big tool space that's
Okay.
in there.
Cool.
That's the CNC and, the mills.
Workshop.
Yeah. Standard stuff. And then out here, we have the automated equipment. So
Okay.
all of our 3D printers.
Okay.
All the things that run off of CAD files.
Cool.
We could have come up with a process to have, screw and drill these parts together, but just the timeline on all of that was
Right.
too much. Instead, you model up a concept, you print it, you go through a couple revolutions
Yeah.
and evolutions on it, and now that process, this thing is done.
Yep.
And we can just keep making shapes at whatever size we need,
Yeah.
whenever we need,
That's cool.
and the process is more or less automated.
Yeah, it frees you up to do other things.
Yeah.
It's kind of like a press go, and
Yeah.
meanwhile you can be thinking about the next
Right.
solution where this is making real the first solution or something.
Yeah,
Very
and
cool.
you can see we've got multiple copies. There's another
Yeah.
dozen sitting over there.
Right.
So when we've got downtime on our 3D printers, the machines just run these extra parts for us.
Very cool.
Reproducibility in the CNC machine is like fantastic.
Got it. Right.
And when we were getting our machine, the guy setting it up was explaining that he will get a machine in their factory, set it up with a program. Its job is to do one part, and they will ship it to a company.
Oh, wow.
And all it does there is one part,
Wow.
and it's already been programmed
Oh, gosh.
and thoroughly figured out for all of its most efficient way.
Yeah.
And that's what all the machine does. So the company might spend $100,000
Yeah.
just to pump out this part over and over and over and over again.
That's interesting. I had no idea because,
Yeah.
to me, that at that point, it's almost like I mentioned this class, we're looking at the framework of industry or industrial automation craft. That sounds like it's using a CNC for an industrial application where it just specializes in doing one thing over and over.
Right. Mm-hmm.
Whereas the framework of automation that we're trying to capture is this superpower of being able to make anything or be agile in what it produces. So you can have it produce, joints one day or pen holders the next.
Yeah.
And so a CNC, like you said, it's capable of producing different things. It sounds like in this context where the CNC supplier is programming a special machine, the end user isn't so concerned about that flexibility. They're just concerned about, doing the one thing.
Right.
But I guess you could make the argument that down the road, if they need to retool or shift the design or something, then perhaps the machine can maybe be updated to do that.
Right. And with machining, the program that's running in this, this specific part yeah, like you can make the tiniest tweak and really change very little inside the machine. Say you're like, I don't like the surface finish, I just need to speed my tool up a little bit.
Got it.
Like nothing really changes in your setup package.
Right.
And so, yeah, you can make those small changes.
And actually, that's another, I think, good distinction for automation to industrial. Like, as far as I know, CNCs have been around, I think, since like the 70s or even probably sooner.
Yeah.
But at that time and at that price point, I'm sure they were large, expensive, like only people, like very specialized production facilities had them. But here we are today where you can get a Prusa for, under $2,000. And so to your point, like, it really just helps that iterative process for students and for research to happen right here in-house and have that turnaround under your nose and like instant, like relatively.
And if you go back, at the beginning of the CNC, right, like you had to use Pro E or some really engineering heavy CAD program that like it was just so dense it was impossible to get into. And now you can start using Rhino and drawing and making shapes from your first minute on the program. So that's changed a lot too. And me being able to machine parts on a CNC, they've now also taken the CAM packages, right, and put them into SolidWorks and Fusion, and they're
Got it.
I do have to learn a bunch of things about tools and speeds and things like that and feeds to be able to do this, but the barrier to entry in machining is way lower because of this as well. I don't have to learn G-code. I don't have to program G-code. I don't have to do the math to figure out, how to make an arc, how to make your tool arc go from here to here.
Right.
Program does it.
Cool. So the CAD can speak to the machines. The language has been smoothed out. Yeah, that makes sense.
Well, like anything, there's sort of there might be a support structure involved, right?
Okay. Yeah.
Now, we are talking about additive versus subtractive, so then you're dealing with sort of different issues. But, in the CNC, you're cutting your part from a larger block. At some point, that larger block has to be clamped into the, your work holding piece, whatever it's a vise or something like that. And so you need to take into account what you're cutting, and is it eventually going to be freed from that giant block at some point?
Got it.
So, what's running in there right now is very sort of 2D thing, but you don't want your part to fall free from your original material. So there's little sprues holding it on. And when you get it out of the machine, then you have to cut it free and process whatever those parts were. Here, it's different. You're going to deal with something that might have, an undercut, right? So in here, there's a shape, right, that needed to be supported later. So it prints a support material, and then this material gets broken out and taken away.
Okay.
Similarly, for that machine, and you can almost sort of make it out on the screen, there are these support structures that are put in to hold your actual model. All of those things can get clipped off. So you would probably cure it, wash it, cure it, and then once everything's done, then you're going to snip off all of your support structure.
Got it. Okay.
And depending on what your purpose is, you may need to further sand down those points.
So basically the 3D printers are all plastic, right?
Yeah, everything is plastic.
Yeah.
We use PLA.
Okay.
We've used a variety of materials over the years. We used to have a Z-Corp machine, which was like a powder and glue machine.
Okay.
That was super slow, but made pretty nice parts. We had an ABS machine for a long time.
Oh, really?
Before they'd gotten these into this like prosumer level, you had to drop at least $50,000. So we had this ABS machine for a long time. And as you work around this equipment and more people run tests, you find, ABS plastic's not great to work around.
Got it.
So we've kind of tried to avoid having that here. The PLA is supposed to be a little less toxic.
Yeah.
it is basically a light curing resin.
Got it.
I'm not sure what the wavelength on the laser is, but
Okay.
you could pour this into a jar and put it in the front window. I mean, it's UV cured, is
And
what
it
they
would
say,
it would
but
turn solid.
It would turn solid.
Interesting.
So the process with this is, it 3D prints out of the resin. You get it out of there. You wash it. You wash all the excess resin in isopropyl alcohol, and then we've got an oven behind us that has UV and heat, and the
That
combination
cures it.
of those two finishes the curing process. Yeah.
Cool.
So like we were making a clip that you'd run a strap through,
Mm-hmm.
and we were able to 3D print all the plastic parts of it, but when it came to like actually holding the strap in place, plastic wouldn't do the job. So
Got
then
it.
we made the like one component that was needed to be durable. We made it out of aluminum.
Makes sense. Do you ever run like wood or anything?
No, we I
Can you?
You
Do people
probably
do that?
could run wood. I mean, there's probably a better machine if you
For that?
want to do wood, right?
Like a router, maybe?
Yeah, like the CNC
Okay.
routers are a lot
Yeah.
better for that.
Okay.
I think I just more or less stick to aluminum because you don't want to like
Gum.
contaminate the machine with too many other materials
That
like
makes sense.
like wood.
Yeah.
Plastic's pretty good. You can
Okay.
use like a chunk of plastic. When I worked at Motorola, that was almost entirely what they were CNC
Oh,
machining
really?
was acrylic and plastic,
Okay. Delrin.
Delrin,
Okay.
and the like UHMW, the ultra high weight plastics.
The Innovation Center uses automation. You mentioned for the labs, so like that's like doing research and concept development with interdisciplinary sponsors and schools, and that's like trying to find a solution to a problem. It sounds like you do some more practical things, like if the machines aren't being used and the Innovation Center needs a pen holder, you print a pen holder.
Absolutely.
But then it also enables the Innovation Center for its flexibility of like, hey, we need frames that can show, for foam core pinup,
Yeah.
and they need to be different sizes. What's the easiest way to do that
Yeah.
without spending an arm and a leg to have something custom, or having the time to like have to have someone at the Innovation Center like screw and unscrew and cut and like manually spend that time putting all these different sizes together.
Absolutely.
That's really cool.
So it really helps that this is here in the space.
Yep.
We get it off the machine, we're like, oh, that wasn't right.
Got it.
We can make the quick change and start over. It's a lot harder when I've sent a file
Got
to a
it.
company, they've sent me back a quote, so on and so forth.
Right.
Yeah. So automation really helps.
That like iterative process
Yeah.
of like learning.
Yes.
That's really cool.
Yeah. And we're a learning space, right?
Yeah.
And that's just, par for the course.
Yeah.
Yeah.